Hose-type waveguide. Weight reduction of the waveguide is done by using resin, but the structure of the waveguide has remained as a non-hollow, solid pipe. Therefore, we are developing a flexible waveguide that is like a water hose. Besides improving convenience by making the pipe flexible like a hose, the image changes and the application range may expand. We introduce an example in which a waveguide is made by winding a copper foil in a hollow resin hose. Our waveguide is a hollow, soft resin hose with a conductive coating on the outside for electromagnetic wave transfer. Conventional metal waveguides undergo passage, return, and conductive losses, which should be reduced as far as possible. Resin waveguides generate additional dielectric and radiation losses. The dielectric losses are due to absorption by the resin, and radiation losses occurs by leakage due to the insufficient shielding of the thin film conductor. Dielectric and radiation losses are the dominant loss components in resin waveguides. Loss factors in the resin waveguide. In this study, we use a soft elastomer material with excellent properties for forming flexible waveguides. In the 10 GHz band, the relative permittivity and dielectric loss tangent of the resin are epsilon r equals 2.28 and tan delta equals 0.00072, respectively, ensuring very low losses as in a Teflon. Conversely, the conventional metal film deposition techniques of plating, sputtering, and vapor deposition are limited to conductive films with submicron thickness. The required thickness at 10 GHz, estimated from the skin depth relationship, is at least 10 m. Therefore, the film in our prototype was formed by winding an 18 m thick copper foil around the aforementioned resin hose. We investigated several types of foil winding and found that the lowest radiation loss occurs in the H-center configuration of the waveguide. The prototype weighs 67 grams/m and costs $1.30 per meter, enabling a lightweight and inexpensive waveguide. The waveguide has a low loss and low emission, with a transmission characteristic of -0.39 dB/m in the 10 GHz band. Hose-type waveguides. In future application to automated vehicles, it is necessary to install various sensors, for example, high-quality inter-vehicle cameras that requires transmission speeds on the order of several Gbps with high security. Conventional wire harnesses cannot tolerate external noise in transfers on the order of several Gbps. Because the influence of noise increases with transmission speed, we believe that it is necessary to review the transmission line design. As shown in, the proposed waveguide is laid from the front to the back to transmit a camera image. The camera image was transmitted inside the waveguide by using high-speed communication between sensors. Inter-vehicle communication system.